Hello, this is Professor Blackman, and welcome to another lesson. This is Unit 2, Lesson 1, Graphs of Equations. So we're going to look at how to graph linear and non-linear equations using tables. So here on the notes below, you can see that I have f of x equals x, which is the linear equation, x squared, which is the quadratic equation, x cubed, which is the cubic equation. These vertical bars around an x is for absolute value. Whenever x is in the denominator, like the example 1 over x, that is a reciprocal. E to the x is exponential. Ln of x is logarithmic, and the square root of x is a square root function. These are all the parent functions. And so when we talk about transformations and functions moving, we always compare them back to the parent function. So let's go ahead and look at some examples. All right, so right here I have y equals x. So I'm going to go ahead and put a little cross here to represent my origin. And I'm going to build a table using x and y. So this says y equals x. So whatever x is, y is. So if x is -2, then y is -2. If x is -1, then y is -1. If x is 0, 0, x is 1, 1, and so forth. So when we go to plot that, I have 1, 1, 2, 2, 3, 3, -1, -2, -2, -3. So right now you can start to see that line that's formed through all those points. And you have that straight line that is formed crossing right here in the middle through the origin. All right, so let's go ahead and look at this another example of a linear equation. So I'm going to go ahead and build another table, use x, y. And so right now when I have a denominator of 3, I'm going to want to choose x values that are multiples of 3 because it makes it easier. So I'm going to choose -3, 0, and 3. And so if I put in 0, that's the easiest. This becomes 0 minus 2, so that's -2. If I put in a -3, -3 would cancel a negative and 3, giving me 5. 5 minus 2 gives me 3. And if I put in a 3 right here, the 3's canceled, then I have -5 minus 2, which is -7. So now I'm going to go ahead and just put my axis right there. At 0, -2 is a point. And then I'm going to go -3, 3. So 1, 2, 3, 1, 2, 3. That's a point. And +3, -7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And then I'm going to connect those points. Line's a lot straighter than my last one. And you can see that here is my linear equation being graphed right here. All right, let's look at another example. All right, in these examples, we have y equals 3x. So for y equals 3x, we're going to build a table. So we have x and y. So basically what it's saying is 3 times x will give us our y value. So if we choose numbers like -1, 0, 1, and then we do 3 times them, we get -1 times -3 will gives us -3, 0 times it will give us 0, and 1 times 3 gives us 3. So now we can go build a table. Now that our table's built, we can go put it into a graph. And so 0, 0, I'm going to plot. That's my origin. When x is 1, we get 1, 2, 3. That's a point. When x is -1, we get 1, 2, 3. That's a point. And then connect those lines. And it looks something like that. All right, let's look at this one. Y equals 3/2 x plus 1. So I'm going to start by building a table. And again, since I have a fraction with a denominator that's multiplying by x, I'm going to use that denominator of 2 and use that as what I want my numbers to be multiples of. So I'm going to, instead of using, like on this left example, I use -1, 0, and 1. Over here, I'm going to use -2, 0, and -2. So then 0 times it plus 1 gives me 1. Sorry, I already have 1. -2, 0, and 2. And so -2 times 2, 2's cancel, so that's -3 plus 1. -3 plus 1 is -2. And you put in a 2, 2's cancel, you get 3 plus 1, which is 4. All right, and then we're going to go ahead and put that on a graph. So 0, 1 is a point. 2, 4 is a point. 1, 2, 3, 4 is a point. And -2, -2 is a point. And then connect those points. And you can see that they're in a straight line. This is, of course, a linear equation. All right, let's look at our next one. Now, these that are given to us here, if you noticed, all the previous examples were all set in y equals, while these are not set in y equals. So one of the easiest ways that you could do is solve for y. And if you don't know how to solve for y, you can go back and look at my video, my lesson 1.2. And so let's go ahead and take our equation that's given, 8y plus 2x equals 4, and we're going to solve for y. So move this 2x over, and we get 8y equals -2x plus 4, and then we're going to divide by 8, and we get y equals -1/4 x plus 1/2. Now, as you see with this problem, now we have this fraction here and another fraction here. So it's going to be a little bit more challenging for some to graph, but we can still get it done. But again, I'm going to take and use my x, y, and I'm going to use multiples of 4 because I have this denominator of 4 right here. So I'm going to use -4, 0, and 4. And then I'm going to plug it in. -4 cancels the 4 and the negative, so that's 1. 1 plus a half is 1.5. So I'm going to put 1.5. Half here, so this becomes 0. Plug in the 0, you get -4 times 0. Anything times 0 is 0 plus a half. So half. And plug in a 4. 4's cancel. -1 plus 1/2. -1 plus 1/2 would be -half. All right, so let's go ahead and draw an XY graph. And -4, 1.5, 1, 2, 3, 4, up 1.5. 0, 0.5. Right there. And 4, 1, 2, 3, 4, -0.5. And then let's go ahead and connect those dots. All right, so it looks something like that. Now let's look at this one on the right, our number 6. So we're going to do the same thing we did because it's not solved for y for us. When we were building our table, it is easier if it's solved for y. And so I'm going to get 2x over to the other side by subtracting it. And so now I have 8y equals -2x minus 4. Divide each term by 8 to get y by itself. And I get y equals -1/4 x minus 1/2. And so when we compare these two equations, one is y equals 1/4 x plus 1/2, and the other one is minus 1/2. So let's see what that looks like when we build a table. So -4, 0, 4, because again, I have a denominator of 4, so I want to use multiples of 4. Plug in that -4. 4's cancel, negatives cancel. I get 1 minus 1/2, which is 0.5. Plug in 0, I get negative 0.5. And plug in 4. 4's cancel. -1 minus 1/2, negative 1.5. So when you compare their values, all the ones on the right are one value less than the ones on the left. 1.5 is 0.5, 0.5 becomes -0.5, -0.5 is at -1.5. So let's go ahead and graph it. As we go ahead and graph this, -4 is 0.5 is at -1, -2, -3, -4, 0.5, 0, -0.5, and negative and 4, 1, 2, 3, 4, -1.5. And so when we go ahead and connect those dots, and so as you see, everything on the one on the left looks very similar to the one on the right. It's just one lower, which we'll be talking about in future videos. It's called transformations. All right, let's look at another example. All right, now we're going to start graphing nonlinear. So previously, our examples were all linear, so they're all straight lines. Here, if you remember back from the first slide, this is a quadratic equation. So let's go ahead and start by building a table. When building quadratics, I recommend always using -2, -1, 0, 1, 2, especially if it's just an x squared plus or minus something. These are the kind of the best numbers to use. So if you plug in -2, -2 times -2 is +4. -1 times -1 is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. And so we have these what we call symmetric points here and here. These are what we call symmetric points. And the point in the middle is what we call the vertex. When you are doing your homework on a program like MyLab Math, you always have to graph the vertex first. So let's go ahead and look at what that graph looks like. And so the vertex is always graphed first. And then you can pick any of your other points. So -1, 1, 1, 1, 2, 4, and -2, 4. And you get this shape that kind of looks like a U, and we call that shape a parabola. All right, so now let's look at y equals x squared plus 3. So basically, we're going to have all the same values, except the y values will all be 3 higher. So we're going to use the same 5x points, 5x values, and we're going to plug in -2. -2 squared is 4, and then we're going to add 3 to it. So 7. -1 squared is 1. Add 3 to it, you get 4. 0 squared 0 plus 3 is 3. And then because of symmetric points, we know this is going to be 4 and 7. And so when we go to graph it, now 0, 1, 2, 3, that's a point. And then I have -1, 4, 1, 4, -2, 7. So 3, 4, 5, 6, 7, and 2, 7. And you can see those symmetric points again being formed. And so then we have our parabola shape looking like that. All right, let's look at another example. All right, so now we have a rational. Now, for rational, I will tell you, if you're using a program like MyLab Math, you are never required to graph these by hand. They're almost always, if not always, just matching. So I'm going to go ahead and put my lines here. And so you have x, y. And so let's say we use -2, -1, 0, 1, 2. Okay. When using these numbers, you get, well, 1 divided by -2 is -1/2. -1 divided by 1, or 1 divided by -1 is -1. 0 here, this is undefined because we cannot divide by 0. And then 1 divided by 1 is 1, and then we get 1/2. And so when we go to plot this, we have 1, 1, and 2, 1/2. And then we have -1, -1, and -2, 1/2. So we don't really get a lot of going on, and we know it can't be 0 at all because it's undefined. So we need to throw in another point, let's say -1/2. -1/2 generates a -2. And if you throw in a 1/2, you generate a 2. And so now we see this half generating this, and then this one half, -1/2 generates the -2, and half generates 2. And so now you kind of see this curve, and we can just throw in some values. If we say 5, then we get 1/5. If we say 10, we get 1/10. And so it actually ends up looking like this curve that's here. And so it looks like that. Now, so we have values all over here in quadrant 1, and we have values over here in quadrant 3. And that's all we've got. Now, for when it's negative, well, basically this is all going to turn all your y values that are positive, negative, or your negative values positive. So if I throw in the same values, so this generated a -1/2 on the example on the left, so now it's going to generate a positive 1/2. And this would be a +1, a +2, a -2, a -1, and a -1/2. So we have values that are negative, positive, so that's going to be all values in quadrant 2. And we have values that are positive, negative, so that's all values in quadrant 4. So this one will end up looking like that. And let me try that again. And like that. And so it's just something you can quickly, easily spot whenever you're doing rational functions. They're either going to be in quadrant 1 and 3 if it's a positive in front, or quadrant 2 and 4 if it's negative in front. All right, let's look at another example. All right, so this is absolute value. So let's go ahead and start by building a table. And so we're going to use x, y. We're going to use the same x values that we do with quadratics. Now, if you remember with absolute value always generates a positive number. So -2 plugged in is a +2. -1 plugged in is 1, 0, 1, 2. So it always generates a positive number. And so now when we go to graph that, and as you see, just like with quadratics, we have symmetric points. So you always want to graph that turning point of, some people call it a vertex, but that turning point first. So we are going to take and put 0, 0, 1, 1, -1, 1, 2, 2, -2, 2. And then draw our function, and it looks like that. So with quadratics, it looks more like a U. It's a curve. To me, absolute value looks more like a V. Okay, so let's go ahead and look at our 1 on the right. So I'm going to use same values again. Okay. And if I put in a -2, -2 gives me -4, but that's a +4. Plug in a -1. Uh, -1 minus 2 is -3, which is a +3. 0 minus 2 is a -2, which is now a +2. Plug in a 1. 1 minus 2 gives 1 minus 2 gives me -1, which is a +1. Plug in 2, I get 0. So as you see with this example, we don't have symmetric points. But we need to find that turning point because that's what we have to graph first. So we need to make sure we get a symmetric point. So what you need to think about is what values of x is going to make this function the lowest. And so with absolute value, it always generates positive. So we need to make sure we can always generate a 0. Well, we do have the 0 here because when you plug in a 2, 2 minus 2 gives you 0. So what we can do is just look at the other points on the other side of 2. If I plug in a 3, 3 minus 2 gives me 1. Plug in 4, 4 minus 2 gives me 2. So now I can see those symmetric points there. And so this right here, the 2, 0 is what we need to graph first. So put in your 2, 0. Put in your 3, 1, your 1, 1. Put in your 4, 2, and your 0, 2. And now you have your symmetric points. All right, let's look at another example. In these examples, we have cubic. You can tell it's cubic because it's x cubed. So with cubic, you're going to want to have some negative and some positive values so you can kind of see the shape of it. And if you use the same 5x points that we use for quadratic and absolute value, it works out pretty good. So x cubed would be -8. -1 times -1 times -1 would be -1. 0 times itself is 0. 1 times 1 times 1 gives me 1. 2 times 2 times 2 gives me 8. So let's go ahead and put that on a graph. So we have 0, 0, 1, 1, and 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, and -2, 1, 2, 3, 4, 5, 6, 7, 8. And so this I always thought cubic functions kind of look like lightning bolts, but this is what the shape of a cubic function. All right, let's do it with -3. So basically all it's going to do is take our y values and go 3 less with them. Using the same x values, -2 through 2, put in y, -2 times -2 times -2 is -8. Take away 3 more, you're at -11. -1 becomes -4. 0 becomes -3. 1 times 1 times 1 minus 3 would be -2. 2 times 2 times 2 is 8. Minus 3 gives me 5. And now we can look what that looks like. Line got a little crooked there. 0 is at -3. -1's at -4. -2 is at -11. 4, 5, 6, 7, 8, 9, 10, 11. 1 is at -2. And 2 is at 1, 2, 3, 4, 5. So it's the same shape, just moved down. Everything's moved down 3, which is again a different type of transformation. That's all I have for you today, and happy studying.